Hi everyone. A couple of months ago, I realized I could use AI to turn back time, or at least try to. If you've seen my channel, you know there's one woman at the center of it all. She's a retired actress from Hong Kong. Her career was unfairly derailed by a toxic industry because she refused to trade dignity for cheap fame. As a fan, I care about her legacy. So, when generative AI took over my YouTube feed, I had a thought. Can I use this technology to reimagine her career? Can I cast her in the roles she never got to play in a way that feels respectful instead of exploitative? I call this ethical deepfake without consent. Since then, I've been testing popular AI methods against one and only goal: bringing Lisa back to the screen. Before diving into the details, I want to point out two distinctive problems I'm facing that break almost all usual tricks to maintain character consistency. First, I don't have high-quality images of her. No studio portraits. No 360-degree coverage. No way to get them, either. For the specific Lisa look I'm obsessed with recreating, all I have are VHS-level TV screen grabs from this one TV show from 1989. Secondly, I know exactly how she looks, and worse, I know how she looks in action. A passable morph means a completely different person in my eyes. So, let's start with what absolutely does not work. Google. The APIs, the workflows, the models. In my case, nothing works. And the reason is just one word: censorship. When Google isn't stopping me from uploading reference images, it's busy morphing my Lisa into Michelle Yeoh. Does suck though, to be locked out of the Google universe, since one clean way to keep character consistency these days is by using a character sheet as a reference. I first learned it from AI Video School. Then I tested it in a 15-second Lisa concept piece. I don't know what to say, besides it works. But how did I make this test if Google doesn't allow me to create or upload a real person to its system? This question leads to the next method, OpenArt Character 2.0, which allows you to upload up to 4 images, front, back, left, right, essentially the building blocks of a character sheet. Then you're ready to bypass Google censorship. It's very straightforward. First, generate the character sheet using Character 2.0's built-in Create Visuals feature with any image model that's not Google. You don't need ByteDance's performative new tool, any old model can do. Next, bring it back to Google, and now you can start the ingredients to video pipeline again. Think of this as AI money laundering. You just need to make a human face AI enough to trick an AI to believe it isn't a human. But even with this workaround, I still get censored left and right whenever I use Google Flow for my Lisa projects. So I have to start looking at open source options, which brings us to LoRA training. In theory, it should solve my problem. In practice, it's complicated. A successful LoRA depends heavily on the quality of the training data. And like I mentioned earlier, my dataset is flawed by default. As a result, the LoRAs I trained were weak. At best, they influence the style of the output, but they can't override existing faces. Both my Quen and Flux LoRAs worked reasonably well in text-to-image workflows, but broke down when I applied them to an existing composition. I also tried the SDXL IP adapter workflow, but without a strong SDXL LoRA behind it, the results weren't just bad, but traumatizing. At that point, it became clear, the real problem isn't the models, it's the training data. Out of frustration, I stumbled onto something surprisingly solid, Ideogram's magic fill feature. Caleb from Curious Refuge once said this is one of the most underrated tools in the entire AI filmmaking space, and I agree. It's basically Photoshop for fools. You do get the best result when the target and base faces look in roughly the same direction. When it comes to image to video, every model falls short. The issue stems from a fundamental flaw in how AI animates a still frame. We know traditional motion pictures work by showing you 24 to 120 frames per second. Each frame is slightly different from the previous one. When played fast enough, your brain perceives smooth motion, the classic flipbook effect. But AI video doesn't work that way. Instead of modifying the previous frame, AI models repaint each frame from scratch. Hallucination isn't a bug. It's part of the process. Even for a 3-second clip at 24 FPS rate and with first and last frames set, AI has the liberty to drift 70 frames in between. That is 70 ways to drift away from what you want. Maybe Seedance 2.0 fixed this, but I haven't tested it since its access is limited in the US. Some people say LTX2 LoRA might help with this, because it teaches the video model how to render your character consistently in motion. I haven't found time to test this out either. If you've tried it, let me know in the comments. Does it actually work? Then there's Kling's motion control. Initially, I thought I could transfer Lisa's own performance to her AI clone, but it works best when the driving performance closely matches the target shot, which isn't an easy requirement in my case. The alternative is to perform the motion yourself and project it onto the character. But I'm not an actor. One thing I learned from my mistake is using Kling 2.6, not 01, because 2.6 allows partial transfer. The partial transfer is a useful tool when you just want some of the driving performance's elements, such as the actor's facial expression change. So this is where I am right now with my grand experiment. I'll keep testing things and share any breakthrough. That's all for today. See you next time.